Hey folks, Mr. Dell here. We are going to be looking at solving equations. This is solving quadratic equations. The quadratic means they have a degree of 2. So let's run through these questions and we'll go from there. So this is coming from CPM Math 2, so integrated 2, and this is section 6.2.3, number 74, 6-74. So it says for each equation below, solve for W, show all your work. So here's this one here. So we'll look at A first. A, notice we just have our only term with a variable is that W squared. So what we can do with this question is just isolate that W squared and then use inverse operations, right? So over here on B, I want to show you the difference. B, we have more than just the W squared term. We also have a W term. So those are two different terms with W. So we're not going to be able to use the same method on both questions. And then here we just have a single W squared term, so we also can use the first method that I'm going to show you for A. So this method here is just what we're looking at on A is just like we would solve a linear equation, a single degree. Our goal is to get our W alone. We want to know what is that W, what number makes this equation true? 5 times something squared is equal to 17. So 5 times something squared is 17. That's what we want to figure out. So to solve this, the first thing is I want to isolate my W squared, right? So I'm going to divide both sides by 5 because the operation between the 5 and the W squared is multiplication. So you do the inverse operation, which is division. That becomes a 1. And you end up now with W squared is equal to 17 over 5. You can leave the number as a fraction because that doesn't divide evenly. Yes, I could use a calculator and get myself the decimal equivalent, but just for the sake of, I don't have my calculator here, I'm going to just leave that as a 17 over 5. So now I want to go from this W squared to a single W. Well, the inverse operation of undoing a squared is square root, right? So W squared is W times W. So what we're looking for is what number times itself. If I square root this, the square root of a squared just simply gives me my whatever's inside. In this case, just the W. So it's the square root and squared cancel each other out. So what I do to one side of an equation, though, I also have to do the other. So I end up with this answer of the square root of 17 fifths. And again, 17 fifths, it's not a perfect square, so I can leave it as is. The one thing I do need to remember, though, is my answer could be a positive or negative, the square root of 17 fifths. And why is that? Because when we think about this squared component, anything squared, whether it's positive or negative, would always be positive. So if I squared a negative number, it would just still be a positive. So that's why when we square root two sides of an equation, we have to always consider the positive and negative solution. So that's our answer here for number 1, or A, is the positive or negative answer of the square root of 17 fifths. Okay. And again, you could get an approximate answer for this if you'd like to do the math in your calculator. This one here. Now this one, we've got, like I said before, you've got both a squared and a linear W, just a W to the first. So with this, we can use the quadratic formula. Those are our choices. Or we could factor and use zero product property, or we could complete the square. So in this case, I'm going to go ahead and use a quadratic formula. So we'll use that. Remember, a quadratic formula is this, and I'll bring it down here. If ax squared plus bx plus c, get rid of that line for now, is equal to 0, right? If you have it, and that's the form we're in right here, if you're in this form, a, b, and c, you can find your a, b, and c based on the form, then what's always true is x is equal to the opposite of b, or negative b, plus or minus the square root of b squared minus 4ac, all divided by 2a. So this is the quadratic formula or quadratic equation that we can utilize when solving any quadratic. Okay, so you will use this one then. So what do I see? I need my a, b, and c, right? So a is the 5, b is, so a is 5, b is this negative 3, and C is the negative 17. You got to pay attention to the operation, the signs in front, because according to my formula, you end up having to have those pluses. So, okay, so let's run through this. So x is equal to negative b. So we're going to start there. So right now b is negative 3, so negative negative makes it a positive. So that's why we say opposite of b. Plus or minus the square root of b squared. So that's going to be negative 3. I'll just write it out for you, squared. And then minus 4 times a times c, right? All of that's divided by 2 times a. So I'm just plugging in my values a, b, and c into the quadratic formula. Let's simplify that. So that's 3 plus or minus the square root of, that becomes 9, negative 3 squared. Notice I have a minus 4 times 5 times negative 17, so all that's going to become a plus. Let's see. That's going to be 20 times 17. This is where I probably should have a calculator in front of me. 20 times 17 is... Brain doesn't want to work very quickly today. 340. I should have known that. 340. Okay. And then all of that divided by 10. So let's keep going. Simplify this up. So we have 3 plus or minus the square root of 349 all over 10. 349 is not a perfect square. So I could simplify my answer and I could get the approximate answer to it, or I could just leave it as is. So I'm gonna just, for the sake of, again, we can leave our answer in exact form. And so in exact form, that would be my answer, is x is equal to 3 plus or minus the square root of 349 all over 10. And again, I could throw all this in a calculator, get 2 approximate answers, or just leave it exact. Last one, we're going to use this, do the same thing we did for a. So I'm going to try to get my w squared alone. And so I ended up with w squared is equal to negative 3. And remember that, what did we do? We square root both sides to get my answer. So in this case, square root of w squared is w, correct? But I have the square root of a negative 3. Now, sometimes, depending upon what level you're at, this would be no solution, no real solution, because you can't take the square root of a negative number. But one of the things we do know is the square root of negative 1 is I. It's an imaginary number. So I can actually write my answer as I times the square root of 3. So, and it would be, again, plus or minus, positive or negative, because you have that, you're square rooting both sides of an equation. So there's our solutions. There you go.